And now in this lecture we learn about the cooling coil selection using psychrometric analysis. So first of all, here you select, this is our psychrometric process, so we can add fresh air condition and CFM. So you can just write fresh air, and now here you can define CFM. Let's suppose we have 6000 fresh air CFM, so here we can write the conditions of CFM of fresh air. So the fresh air is 110 Fahrenheit temperature and relative humidity of 14.5 Fahrenheit. So you can apply this point. Now after applying this point you can add point. So here you can write cooling coil, and here you can add this. So here you see, you select this cooling coil. After selecting cooling coil you can select start point. So start point is over fresh air. So now here we can select method. So we having two method, one is energy method, so we can select energy method. So now these all are on coil condition. So on coil we have relative humidity greater than 90%. So we can add latent and sensible energy, and at that point we have relative humidity of 90%. So you can add 14,000 BTU of, you can add here 30,000 BTU of your sensible energy. So I will add 3 lakh. So here we get relative humidity of 61%. And if we have 12,000 relative latent heat, then we have 58.99 relative humidity. So we can increase our sensible energy. So you can add here 4,000, 40,000, 4 lakh. So at 3 lakh 96,000 we have 100% relative humidity. So we decrease this amount. So here we can write 0, 96%, 95% is okay. So we add here 80, so 91%. So 91% is also okay. We can apply this point, and now we get this cooling coil condition at there. So if we want, we can also increase this latent energy little bit, because it's very low, 18,000. we having 80,000, and we write here 88. So this is perfect. So these are conditions of our cooling coil. So now this is the graph of cooling coil, that we get 93.2% relative humidity. So after that we add another point, which is sensible heating. So you can add this point, sensible heating, select this cooling coil, and we want to get 75 Fahrenheit temperature. So apply this. So after sensible heating we get this. Now we can save this report and analyze this. Now here we can write here cooling coil analysis selection, and this is our report. And now we have chart. This is our psychrometrics chart. Now here we can open this. This is report. So now here you see we have 6000 CFM at dryable temperature of 110 Fahrenheit and relative humidity of 14.5%. So on coil condition we have a dryable temperature of 50 Fahrenheit and relative humidity of 93%. But when we and then we have dew point temperature of 48.9, approximately 49 Fahrenheit, enthalpy of this specific volume 13.0, humidity, we get all these values of our cooling coil. So this is the total energy required for cooling coil. So we our cooling coil is 34 ton, so the load of cooling coil is 34 ton. If we want to get this temperature and relative humidity, we use 33.9 ton cooling coil, and then we can for achieving our comfortable level of temperature, like dryable temperature 50 degree Fahrenheit, we can add we should add sensible heating. So when we heat our air and for 75 Fahrenheit, so we use heater capacity of 13.2 ton, which is approximately, we use calculator for calculating this. So 13.5 multiplied by 3.516, so we convert into kilowatt. So sorry, this is incorrect. 13.5 multiplied by 3.516, so we have 47 kilowatt heater. We use 47 kilowatt heater, and we get 40% relative humidity. As you know that the comfortable level of relative humidity for human is 40 to 60% relative humidity, and this is our comfortable temperature.